Let's look at this question which was asked in Chemistry 2010. That is question B4 on atomic structure. So the question was, red light of wavelength 700 nanometer is incident on the surface of cesium, which has a wave function of 2.3 times 10 to the power negative 19 joules. Calculate the energy of a single photon of red light and determine whether it can cause emission. So how can we solve this question? So we are going to use a formula which relates energy, frequency, and Planck's constant. So we know that energy is equal to Planck's constant multiplied by the frequency, but from the wave equation we say speed of light is equal to frequency multiplied by the wavelength. Since in this question what we have is the wavelength, so we can make wave and frequency the subject of the formula. So we can divide by wavelength on both sides, even here by wavelength. So what we are going to have basically will be frequency is equal to speed of light over wavelength. So we can substitute there to say frequency will be equal to speed of light over wavelength. So our energy will be equal to Planck's constant multiplied by speed of light. We are substituting this on the frequency, speed of light over wavelength. So this is the formula we are going to use. So what we have basically is energy is equal to Planck's constant multiplied by speed of light over the wavelength. So we can do the substitution. So energy will be equal to Planck's constant is given on the cover leaf page, so there is no need to master. It is 6.626 times 10 to the power negative 34, and these are joules second. Those are the units. Multiplied by speed of light is 2.99 times 10 to the power 8 meters per second, but you can say 3 times 10 to the power 8 meters per second. Then you divide everything by the wavelength which was given, which is 700 in a nanometer. Nano means 10 to the power 9, so it will be 10 to the power negative 9 meters. So we're going to say energy will be equal to, if you punch this on your calculator, 6.626 times 10 to the power negative 34 multiplied by 3 times 10 to the power 8 divided by 700 times 10 to the power negative 9. We are going to have energy will be equal to 2.839714286 times 10 to the power negative 19 joules. So you can even round it off. we can say energy is equal to three significant figures. It will be 2.84 joules. So this next question was determine whether it can cause photo emission. So for photo emission to occur, photo emission is simply the process by which electrons are emitted from a surface of a substance or a metallic substance when light strikes on it. So that is photo emission. Photo means light, so light strikes on a metallic surface, then electrons are emitted. That is photo emission. So the condition there is that for photo emission to take place, the threshold, the incident energy must be greater than the work function or the threshold energy or the threshold frequency. Okay, so the threshold frequency, that is just the minimum amount of frequency or the minimum energy that has to be overcome by the incident frequency, so for photo emission to take place. So that is the condition. So in this question, the work function we've been given is 2.3 times 10 to the power negative 19. That is the work function, and our energy was 2.84 times 10 to the power negative 19 joules. We can see that the energy which we found, our energy 2.84 times 10 to the power negative 9 is greater than 2.3 times 10 to the power negative 19. So energy we found is greater than the work function. So what can we conclude? So we are safe to say that yes, photo emission will occur. Okay, the photo emission will occur because the incident energy is actually greater than the threshold energy or the work function. So this is how you can basically answer this question.